Okay, welcome back. This is just video 2 of this section, 1.8. We're going to talk about mixture problems. So here we go. It's kind of a silly one, but a mad scientist, has a supply of a 45% solution of kilbondonium and an endless supply of an 85% solution. He needs 30 gallons of a 60% solution in order to go after James. How much of each should he use? So the idea here is that we have two mixtures. We have a 45% solution of whatever this kilbondonium is, right? Which means if you were to be able to separate it, then 45% of it would be the actual, let's say it's an acid, because it's easier to think of it as an acid, then the actual acid would be 45% of the whole solution, and the rest of this would probably be something like water or oil or something, whatever that acid got dissolved into, right? But I have this much acid in that container, right? The thing that I don't know about this container is how much I want to use, right? So I'm going to call that X, and that's the, and since we're looking for gallons, right, I'm going to call this the number of gallons of the 45% solution. We're going to call that X, right? We have an 85% solution, meaning in this other solution, most of it, right? A pretty good chunk of it. 85% of it is this acid, this kilbondonium, and the rest is water, right? And what we're doing is mixing these two together. I'm taking a certain amount of this, a certain amount of this, and I'm going to turn it into, hopefully, this 30 gallons of 60% solution, right? But since I'm mixing these together, if I've already dumped in X gallons of one, the other one, very similar to the coin problem, very similar to the coffee problem, is going to be the difference between what I want and what I've already designated as one of those things. So that is 30 minus X. And that's the number of gallons of the 85% solution, right? And in the end, I want this to be a solution that is 60%, right? So, you know, somewhere over there of this acid or whatever it is we're talking about, right? And I want this to be 30 gallons. So the equation here is not terribly difficult, but it is weird to look at it for the first time, right? So let's write it. I'm going to get rid of the problem up here, so when I have some space to write the equation. But it's essentially this. However much acid is here, gets added to however much acid is here, and that's going to be the amount of acid that's there, right? And that's my equation. Acid from this plus acid from this equals acid here. So our units in the first problem were dollars. In the second problem were also dollars, right? In this case, it's going to be acid, right? Gallons of acid. So how many gallons of acid do I have here? Well, I have 45% of my mixture is acid, and so it's 45% of however much I mix together. So that is to say 0.45 X. That's the amount of acid that comes to the table from jar 1. Right? The amount of acid that comes to the table from jar 2 is 85% of this 30 minus X. So, plus 0.85 times 30 minus X. I think I'm going too high probably. Let me start over and maybe lower this. I start going a little slanty up there. Excuse me. minus x Alright, that looks better. Okay. So the total amount of acid that I dump into the container from jar 1 plus the total amount of acid that I dump into the container from jar 2 should be the total amount of acid that's in jar 3. And so that is 60% of 30 gallons. So 0.6, that's 60% as a decimal, multiplied by my 30 gallons. Right? And that's my equation. So, at this point, once again, we have decimals, right? Don't be scared of decimals. But we've essentially reduced it all the way down to a section 1.4, 1.3 problem again, right? So let's take and distribute this. This 0.45x is going to stay. Here I've got 0.85 times 30 is 25.5 minus 0.85x equals 18. Let me get rid of my beautiful picture here. It is beautiful, isn't it? I can combine like terms. 0.45x and negative 0.85x is negative 0.4x. Plus 25.5 equals 18. Right? Use the addition principle, subtract 25.5. That leaves me with negative 0.4x equals negative 7.5. Right? And then, excuse me, we'll divide each side by negative 0.4. That gives me x equals, the negatives cancel out, and that leaves me with 18.75. Right. So, and again, I've had to erase mine because we're limited board space here, but you should have this written in your notes, that x was the amount of, I can't remember now. I think it was 45%. It might have been 40. I don't remember. But I have this many gallons. It's, 45. It's 45%, right? Of 45% mixture. And then this 30 minus x is simply 30 minus this 18.75, right? So that's 11.25. Of the 85% mixture. Right. And there we have it. Okay. Thank you. We'll see you on the next section.